Hello fellows, welcome back to channel Allsmiles. So in this today's video we are going to learn about James Webb Space Telescope. So let's firstly see our intro. So let's go into the video now. James Webb Space Telescope was launched aboard an Ariane 5 rocket on December 25th. Now let's learn about the four key goals of James Webb Space Telescope. So let's learn about the first one. After the Big Bang, what were the first stars and galaxies? Now let's learn about the second one, which
To study the formation and evolution of galaxies.
now let's learn about the third one. To understand the formation of stars and planetary system. Now let's learn about the last one, fourth one, to study the origin of universe. These all can be done because of its unique features which are also not available in Hubble Space Telescope. What are the four scientific instruments of James Webb Space Telescope which are also very different from Hubble Space Telescope? Because of sun shield protection. This can be seen that it's the sunscreen of the telescope. It will protect from the UV rays of the sun. This is because the space temperature will be minus 270.45 degrees Celsius. Yes, guys, it's very cold in space. To resist from the sun's temperature, they have placed 5 layers of Kapton E metal, which is as thin as hair. And also, they coated the screens with aluminium and silica, as they can reflect the sun's rays. Because of it, the sun shield's other side will be cool. The size of the sunscreen is as big as a tennis court, but it is designed in a way that it can easily be folded and easily carried while the launch. Now we will talk about the part in which 25 lakh rupees of gold is placed. Yeah, guys, you heard it true. But why only gold, aluminum, or silica, which they used in Hubble Space Telescope? Because gold is an extremely unreactive metal, and gold reflects 99% of infrared light, means the telescope will be cold. Webb is the first telescope in which gold is present. The primary mirrors of James Webb Space Telescope are 21.4 feet, which is an average height of a giraffe. And I know that you all are thinking about such large telescope, how it can be carried into the space. I am here for that, guys. To avoid that, they have divided 18 hexagonal segments, where each segment is equal to 4.3 feet. After reaching the segments into the space, the telescope stretches using the 126 small motors, means the mirror settings will smoothly done after reaching into the space. Now we will talk about ISIM, Integrated Science Instrument Module, and also we will learn about spacecraft bus. Now we will discuss the core structures of the telescope where the whole telescope is dependent. ISIM, Integrated Science Instrument Module. We can think this as the brain of the telescope, means it will control all the parts of the telescope. Now let's learn about the spacecraft bus, which is the primary support component of the telescope. ISIM, Integrated Science Instrument Module, is a framework that provides electrical power, computing resources, cooling capability, as well as structural stability to the Webb telescope. It is made with bonded graphite epoxy, means we can say it that it's the favicol of the telescope which keeps attached. Now we will talk about the weight of the telescope. The weight of the telescope is about 6,200 kgs. You all will get a doubt that such huge weight, how would it be reached to the space? The James Webb Space Telescope will launch on an Ariane 5 rocket from the Guyana Space Center in Kourou. After the launch of 26 minutes, it will be reached into the space and the telescope will be detached. After 1 month, it will reach its destination L2. Now, what's L2? L2 is also known as Lagrange point 2. Why it's Lagrange point 2? Because there are 5 Lagrange points. So now let's learn what are Lagrange points. Lagrange points are the points where the sun's and earth's gravity is balanced. This gravitational balance allows any object to revolve around. But why only L2? Why not other points? There are 5 points: L1, L2, L3, L4 and L5. Now let's learn. L2 is about 1.5 million kilometers long in the sun's opposite direction. We all know that objects which are millions and miles far from the sun will take more than 1 year to revolve. But according to L2, sun and earth are in unison. So using the boat's gravity, the telescope will get extra boost and energy, in which it will sync with the early orbit of Earth. This location helps the telescope to see the universe, which are millions of light years far. And now I'm going to say that, but the telescope won't start studying the universe until 6 months. after reaching L2, because it need to study all the things about the universe, and then it need to say. So now I am going to say that this is the end of the video. If you love the video, click the like button and the share button, and if you also love the video, subscribe. Till then, goodbye, we will meet in another episode. Till then, bye.